Go ahead, take a look at the shirt you're wearing right now. Feels pretty simple, doesn't it? Just a piece of fabric. But woven into those very fibers is this huge, complicated story that starts long before it ever hit a store shelf. Okay, let's get into it. We're going to unravel the hidden environmental cost of cotton and explore a really cool scientific breakthrough that could honestly change everything.
It's a weird question, right? But it gets straight to the heart of what we're talking about. The journey our clothes take, from a plant growing in a field to a hanger in our closet, well, it's an incredibly thirsty one.
And this diagram gives us a perfect map of that journey. Just look at all those steps on the right side labeled wet processes. You've got sizing, desizing, scouring, bleaching, dyeing. Every single one of these, especially where you see the arrows for water and chemicals, adds up to this massive environmental footprint.
So just how big of a problem is this really? Well, the amount of water the textile industry drinks up is just staggering. It puts this enormous pressure on our planet's most important resource. And this chart shows you exactly where it all starts. Way before a single thread hits a factory, the raw material itself has to be grown. What you're seeing here is groundwater use for agriculture, and it's so clear how crops like cotton are a huge reason we're using up so much water all over the world. Now, once that cotton actually gets to the factory, the numbers get even crazier. Just look at the range for woven fabric. That's the stuff in a lot of shirts and pants. It can take over 500 liters of water to process a single kilogram of fabric. That is an unbelievable amount of water for what is, just a couple of pounds of material.
Okay, so let's zoom in a bit. We've seen the big picture, now let's focus on one absolutely critical stage. Before any fabric can be dyed that perfect color you love, it has to be cleaned and prepped. Big time.
So raw cotton fabric, which the industry calls gray cloth, isn't exactly clean. It's actually full of natural gunk and stuff they use in weaving. To get it ready for color, it goes through this whole cleaning boot camp. And the step we're going to zero in on today is number 2, scouring.
So what the heck is scouring? Honestly, the best way to think about it is an industrial-strength deep clean. Its whole job is to strip away all the natural impurities, all the waxes, the oils, the sticky stuff called pectins that are just part of raw cotton, leaving behind nothing but pure cellulose fiber. And here is why that is so important. Scouring makes the fabric hydrophilic. It's just a sciencey way of saying it makes the fabric love water. The whole process turns naturally water-repellent cotton into a super thirsty sponge, and that is absolutely essential for it to soak up dye evenly. If you don't scour it properly, you get a splotchy, low-quality mess. For decades, the way the industry has done this is, well, it's basically a brute force attack. It works, for sure, but it comes at a pretty heavy environmental price. So, let's picture a traditional scouring operation. They load the fabric into these huge iron vats, dunk it in a solution of caustic soda, which is really harsh stuff, and then they basically boil it under pressure at temperatures around 90 degrees Celsius. That's almost boiling. This uses a ridiculous amount of energy, and the chemical wastewater it creates is a huge pollutant.
So if you were to put it on a scorecard, the old-school chemical method looks like this: high heat, harsh chemicals, super high energy use, and a big negative environmental impact. But what if there was another way? And this is where the story gets really interesting. To solve this problem, scientists didn't build a bigger machine. They looked to the natural world. Instead of that chemical hammer, they went looking for a more elegant biological tool.
And they found it in bacteria. They were able to isolate these specific enzymes. Now, enzymes are just natural proteins that act like tiny little biological machines. You can think of them as microscopic surgeons that are programmed to go in and precisely cut away only the impurities in the cotton, just the waxes and pectins, without needing any harsh chemicals or intense heat. And this is the number that changes the entire game. These little enzymes do their absolute best work at just 50 degrees Celsius. That is a 40-degree drop from the old method. The potential energy savings here are just massive.
So let's go back and finish our comparison chart. The new method, bioscouring, uses low heat with a natural catalyst, which means it uses way less energy and has a much lower environmental impact. I mean, look at that. On every single metric, it is a cleaner, greener, better process. It's a total slam dunk.
But here's the real kicker. You might think, okay, a gentler, lower energy process, maybe it's not quite as effective. Well, look at this. The fabric on the right, the one treated with enzymes, is actually visibly whiter and brighter than the one that went through the harsh chemical bath.
And the hard data from the research totally confirms what our eyes are telling us. The bioscoured fabric was measurably whiter and brighter and way less yellow. So get this eco-friendly process doesn't just match the old way, it actually makes a higher quality product. That is a serious win-win.
So this one single innovation really opens the door to a much bigger conversation about the future of how we make our clothes. It's all about working smarter, not harder.
And this isn't just about scouring. As you can see in this diagram, these biological tools, these enzymes, can be used all across the production line, from desizing to bleaching to finishing. It's really a fundamental shift in thinking, using biotechnology to slash pollution, save water, and cut energy use.
So the real takeaway here is that there isn't one single silver bullet. The path to a sustainable future is all about combining these smart solutions. It's about pairing biotechnology like these enzymes with more efficient machines and clever ideas like recycling water. When you put all those pieces together, you can build a textile industry that's not just cleaner, but also more efficient and even cheaper to run.
Which kind of leaves us with one final big question to think about. We usually think of technology as, circuits and steel. But maybe the most powerful and revolutionary technologies, the ones that are going to help us build a truly sustainable world, are the ones we can borrow from nature itself.